Hello, I'll be making this short video to demonstrate an example of how to use and run my program. This program can batch geocode addresses for free and without using the API key. So let's jump right in. I'm starting this video assuming you have PyCharm set up with all the packages and or another project you're using another project IDE. Links to PyCharm, Python 2.7, and my GitHub for the program will be in the description. The hardest package to get is the main package for this project, which is the geocoder package. Once you have all that done, all you need to do is set the path to your input file and then set some variables in the configuration settings section. So for an example, we're just going to be using input CSV, which is this file right here. And as you can see, it has some extra columns in here which you don't need for geocoding, like rural score and region. That's the great thing about pandas, is once we tell it what these are, these columns, it just ignores the other columns. So you need to set this input file, set these two are required, so your addresses, what column your addresses are. So yeah, these need to match addresses, and then state, so what state it's in. Zip code is not required, but I recommend it so that you get more accurate geocoding locations. If you don't have that, you can just leave it blank. Start index is pretty self-explanatory. That is where the program starts in your input file. The reason you do not want to start at 0 is if your program crashed or something happens, so you can pick up where you left off. Status rate, this is going to be how often the program prints the status. So after it's processed 100 addresses, it'll tell you how many it's failed on, if it has failed on any. This is the same idea. After 1,000 addresses, it will write a file. Attempts to geocode. This is how many times the program tries to geocode an address. Now, since we're using this API for free and without a key, it every now and then just says it fails to geocode an address, but in reality it's just because we're using it so much. So we'll attempt to try each address 3 times. And then wait time is the time we tell the program to wait when attempting to geocode the same address again, because we need to wait some time so that we don't bog it down. And then, yeah, so once you have all these set up, then you can run your program. Now, I have all these warnings and red errors because I just set up this environment real quickly, and I mean, that doesn't really matter. As long as you see your program start output this, that means it's starting to run. So we'll just go ahead and let this run for 3,000 as the example. Alright, so it completed the first 1,000 without failing on any, and it did it based on my timer in about 9 minutes. So yeah, it does do, without any errors, it does do about 100 per minute. So if we go and look in our folder, you see that there's an output. So let's open this one up for the first 1,000, see what it looks like. So yeah, this is a column generated by Pandas. We can just delete this, but you'll see your address, which is the combined addresses. Well, combine the address, the zip, and then the state. So you just put it all in one line, and then you have the lat and long, and then the provider. Which this provider, I originally had this in there because I was using Google too, but Google limits you to 2,500 per day, and that's even with an API key. So I decided not to use it, and for other reasons, because for some reason, even if you're hitting it and not getting anything from it, after 2,500 uses, it'll just stop the program. So if you're trying to geocode anything over that, then it just causes the program to halt, which is dumb. But yeah, so yeah, every single one of these was used used ArcGIS. So, in the rare off chance it might use the other one, Komoot, but these are both very, very close and accurate to what Google's API does as well. So, should be good. Okay, so our program finished. It created the final file, and it didn't fail on any of the addresses, which is good. So if we go and look, it created one. It created a file every 1,000 addresses, and so this is our final file. And if we look in here, everything looks good. Yep, all 3,000. So yeah, that's basically it. Alright, thanks for watching.